All right, so after finishing rational expressions and rational equations in 8.8, I'd like to introduce 8.9, which is about variation. In this short section, we're going to talk about three different kinds of variation. The first one is direct variation. So what does that mean? The key word here is direct. When we say the variable y, or any variable, y is just a generic variable, varies directly with x, and again another generic variable, that means y equals k times x. So when there is direct variation, we times by the variable. K is called the variation constant. Well, let me just give you an example so you can understand why do we have to have a k in there before we go on any further. So if I give you this table, x, which is the hours you worked a week, and y is your dollar before taxes and all that stuff. If you worked 30 hours for a specific week and you made $510 before taxes, you want to work 35 hours next week, how much you're gonna make? So we say dollars varies directly as hours. Why is that? Because the more hours you work, the more dollars you make. More of hours, more of dollars. Okay, that's why it's direct variation. So we say y equals, and we must have k because you don't want to have y equals x, because if you work 30 hours, you're gonna work $30 if it was y equals x. So k, how do we find k? When x is 30, y is 510. So in this case, k is actually your hourly rate, how much you're getting an hour, which is $17 an hour. See how important that is, having a k in there. So now y equals 17x. Okay, we'll come back and finish this, but I wanted to show you the significance of having a k there. So direct variation, you take k and times it by the variable. And if you look at page 706, number 18, page 706, number 18, it says express each variable model in symbols. T varies directly as x. T varies directly, so the keyword is directly as x. So T, since it's direct, it's k times x. That's all you have to write for now. Okay, then the second kind of variation is what we call inverse variation. Just like it says, they vary inversely of each other. Like the more of x, the less of y. The more of x, the less of y. The less of x, the more of y. So we say y varies inversely. So you're going to be looking for this word with x if y equals, instead of k times x, when we say inverse, it's divided by x. Like for instance, the more we jog, the less we weigh. The more we drive our car, the less gas we have. Okay, inverse variation. Number 20, page 706, just to explain that, it says v varies inversely as the square of r. V varies inversely as the square of r. So we say v, since it's inverse, k divided by, it's not just r, it's square of r, so we write r square. Okay, then the third kind of variation is what we denote by direct variation. It's not really different from I mean, it's like direct variation. It's not different from the direct variation. It's called joint variation. This is actually multiple direct variation. What do I mean by that? So instead of saying y varies directly as x and directly as z, we say y varies jointly as x and z. So it's a multiple direct variation. Again, instead of saying y varies directly as x and y varies directly as z, We say y varies jointly as x and z. We write it again, it's all multiplication when it's joint variation, no division. Okay, so as an example, the price of a car varies jointly as its model year and packages included. So the price, if P is the price of a car, model year, Y is the year, and the packages, I don't want to use P and just use K for, so we write P equals K times Y. Oh, let's not use K, let's use G for packages, okay, times G. That's what it means. And if you look at 22 from page 706, 22, it says D varies jointly as R and T. D varies jointly as R and T. So D equals K times R times T. So this is just setting up a variation problem, okay? This is basically, if you look at the example, this is only this step. Now, to do the rest, we're actually going to be solving a variation problem. To solve a variation problem, the first thing is you want to write a formula to represent the variation in that problem. So if it's direct, you times by the variable. If it's inverse, you divide by the variable. If it's joint, you multiply as many variables as you have in there. So this was the first step. Write y equals kx. Then, if you notice what we used the given information, working 30 hours, how much we got paid. We use that information, plug it into the formula to find k. Okay, so use the given info to find k. We found k, and then we plug the value of k back into the original formula. Plug the value of k back into the original formula. Once you plug the value of k, you get a formula. Now you can answer the question. Now you can put the 35 in there and answer the question. Answer the question. So you want to write a formula to represent the variation. If it's direct, you times by the variable. If it's inverse, you divide by the variable. If it's joint, you multiply by as many variables as you have. Then you use the given information, you plug in the numbers for all the variables to find k. You plug the value of k back into the original formula, and then you answer the question. Number 36, page 706. It says an object in free fall travels a distance s that's directly proportional to the square of the time t. So s is directly proportional to the square of time t, kt square. If an object falls 1,024 feet in 8 seconds. So that right there, we stop, we plug those numbers in, the feet and the seconds. So since it falls, that's a negative 1,024 k t square, 8 square, so negative 1024 is 64k. Divide by 64. You know, k is gravity, which is it's half the gravity actually. It's negative 16, and it's negative because gravity pulls downward. So once we found k, then we plug it back into the formula, and now we can answer the question. The question says, how far will it fall in 10 seconds? So if t is 10, what is s? Negative 16 times 10 square. so it would have fallen 1600 feet. Okay, negative because it's falling, so it would have fallen 1600 feet in 10 seconds. All right, number 44, page 707. 44, page 707. The number of gallons, so I'll use G for gallons. The number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank, H is the height of the tank, and the square of the radius of its base. R is the radius of the base of the tank, of the tank's base. And it says jointly, so G equals its multiple direct variation, and it's R squared because it says and the square of the radius. Okay, so you gotta be careful for those things. So we set up the formula. Now we need a value for G, H, and R to find K. So let's read on. The constant of proportionality is 23.5. Good for us. So we're given that. We don't even have to find it. Now we can just answer the question. Find the number of gallons. So we want G that can be stored in the cylindrical tank shown. So if you look at the cylindrical tank, the height is 20 and they give us the the diameter. Diameter is 15, but we know the radius is half of that. So radius is 7.5 feet. Be careful, okay? So G is 23.5. Height from the picture is 20 and radius is 7.5. We gotta square that. And how many gallons? 26,437.5 gallons. Well, we didn't have to find K, we were given K. Here's one that we have to find K. 50, page 707. A businessman who sells widgets has found that the revenue, so R is revenue, from their sale varies directly as the advertising budget and inversely as the prices. So A is advertising budget and P is the price. So to write the formula, the revenue varies directly as the advertising budget and inversely, so we divide by the price. When 105,000 was spent on advertisement, so 105,000 was spent on advertisement, and the widgets were priced at $19.95. The revenue from their sale was 200,000. That's the revenue. So we pause right there. Now we can find K. So if you do 105,000 divided by 19.95, you get 5263.1579 equals 200,000. Now you divide 200,000 by that number, by the answer that we just got, and we get 38. So K is 38. Okay, now we take that and put it in there, and then we'll answer the question. 38A over P. How many widgets would he expect to sell at $17.50 each if 700,000 was spent on advertising? So R is 38, 700,000, and what was the price? Lowered the price, so he expected to sell more. 1750, and 38 times 700,000 divided by 1750, and that's 1,520,000. It's a lot more revenue because lowered the price. And that's it from section